Welcome to Star Technology 5G. In the last video, we studied how to receive data using serial communication. In today's video I will show you what is interrupt function and how to enable interrupt function. Let's start the video. Please subscribe to the Star Technology 5G and click on the bell icon. Interrupt function. A single microcontroller can serve several devices. There are two methods by which devices receive service from the microcontroller: interrupt function or polling. In polling, the microcontroller continuously monitors the status of a given device. When the status condition is met, it performs the service. After that, it moves on to monitor the next device until each one is serviced. In the interrupt function method, whenever any device needs the microcontroller's service, the device notifies it by sending an interrupt function signal. Upon receiving an interrupt function signal, the microcontroller stops whatever it is doing and serves the device. The program associated with the interrupt function is called the interrupt function service routine, ISR. The first thing the microcontroller does when an interrupt function request arrives is to execute the current instruction and then stops the regular program execution. As a result, the current program memory address is automatically pushed onto the stack and the default address, predefined by the manufacturer, is written to the program counter. The location from where the program proceeds with execution are called an interrupt function vector. As you can see in the figure, when any device needs a microcontroller service, it will generate an interrupt function request. An interrupt function flag bit will rise, and microcontroller served the interrupt function routine. Enabling and disabling an interrupt functions. All interrupt functions are disabled by default, meaning that none will be responded to by the microcontroller if they are activated. The interrupt functions must be enabled by software for the microcontroller to respond to them. The INTCON register is responsible for enabling and disabling the interrupt functions. Here is INTCON register. Bit 7. GIE, Global Interrupt Function Enable Bit. 1 equals enables all unmasked interrupt functions. 0 equals disables all interrupt functions. Bit 6. PIE, Peripheral Interrupt Function Enable Bit. 1 equals enables all unmasked peripheral interrupt functions. 0 equals disables all peripheral interrupt functions. Bit 5. TMR0IE, TMR0 Overflow Interrupt Function Enable Bit. 1 equals enables the TMR0 interrupt function. 0 equals disables the TMR0 interrupt function. Bit 4. INTE, RB0/INT External Interrupt Function Enable Bit. 1 equals enables the RB0/INT External Interrupt Function. 0 equals disables the RB0/INT External Interrupt Function. Bit 3. RBIE, RB Port Change Interrupt Function Enable Bit. 1 equals enables the RB Port Change Interrupt Function. 0 equals disables the RB Port Change Interrupt Function. Bit 2. TMR0IF, TMR0 Overflow Interrupt Function Flag Bit. 1 equals TMR0 register has overflowed, must be cleared in software. 0 equals TMR0 register did not overflow. Bit 1. INTF, RB0/INT External Interrupt Function Flag Bit. 1 equals the RB0/INT External Interrupt Function occurred, must be cleared in software. 0 equals the RB0/INT External Interrupt Function did not occur. Bit 0. RBIF, RB Port Change Interrupt Function Flag Bit. 1 equals at least one of the RB7, RB4 pins changed state, a mismatch condition will continue to set the bit. Reading port B will end the mismatch condition and allow the bit to be cleared. Must be cleared in software. 0 equals none of the RB7, RB4 pins have changed state. Project, how to enable external interrupt function. In this project, we will enable the external interrupt function and we will turn on and off the LED that is connected with our D0 pin of the PIC16F877 microcontroller, and the microcontroller operated with an 8 MHz crystal. We will use the RB0 pin of the microcontroller that is an external interrupt function pin, and we are using the switch as the input device that will trigger the interrupt function signal. Here is the circuit diagram we are using in our project. It is PIC16F877 microcontroller. Pin number 1 is master reset. If we press the switch, it will reset the microcontroller. Pin RD0 interfaced with LED 1. And we are using the current syncing mode of LED. The value of the resistor is 260 ohm. RB0 is an external interrupt function pin, and here is the pull-up resistor. The value of the resistor is 10K. If we press the switch, microcontroller will receive the interrupt function signal and stop whatever it is doing and serves the device. Pin numbers 13 and 14 interfaces with an 8 MHz crystal. And 22 PF capacitors connected with the crystal. Pin numbers 11 and 32 connected with positive 5 volts. Pin numbers 12 and 31 connected with ground volt. Let's draw this circuit in Proteus. The circuit is ready. Now we will write its code in micro CPIC. Here is the window where we can write the code. I already wrote the code, otherwise video gets very long. I will copy the code. And I will paste it here. Now I will define the code. S-bit LED at port DB0. Define port D bit RD0 as LED. Void delay. Debouncing delay function. Unsigned char x. Define variable. For x equals 0, x less than 10, and increment x. For loop for delay. Void interrupt. Here is the interrupt function. Whenever the microcontroller will receive an interrupt function signal, it will come in interrupt function vector. Delay. That is the debouncing delay. LED equals invert LED. Toggle LED. After receiving the interrupt function signal, we just toggle the LED. Int f equals 0. Clear interrupt function flag. This flag must be clear in software, otherwise microcontroller generates another interrupt function. Void main. Main function. TRISD.RD0 equals 0. Set port D pin RD0 as the output pin. intcon equals 0x90. Enable global interrupt function and external interrupt function. LED1 equals 1 turn off LED1, while 1 stay here. You can see the microcontroller is stayed here doing nothing. Now we will create the hex file. Just click on the build icon. Finished successfully. File is created. Now we will load hex file into the microcontroller. Double click on the microcontroller. Select the hex file. OK. And click on the run simulation. If we press the interrupt function switch microcontroller toggle the LED, you can see the microcontroller is stayed here doing nothing. But still, it is responding to the interrupt function signal. If you have any problem with the code, let me know in the comments. Thanks for watching. Please subscribe to the Star Technology 5G. And keep watching Star Technology 5G.